we're going to return to calculus. So last term, you remember we talked about differentiation and things associated with that. So all I want to really touch on today is just a reminder of the first derivative that we looked at. Different notations, we can have y dash, f dash x, d dx of whatever function it is that we're differentiating, or probably the most common of them all, dy dx. And what it measures, well, it measures the rate of change, but if we're talking about curve sketching, it measures the slope of a tangent at a particular point. Now, that helps us when it comes to drawing curves. Because if you think about a tangent, if the slope is positive, then the actual curve must be going up. So we can look at the sign and we know the direction the curve is travelling when we draw it. So we call that, for obvious reasons, increasing. The curve's going up. If the derivative is negative, well, think of a curve drawing a negative slope, it must be going down. It's on its way down. And then, of course, if it's equal to 0, that's what we call stationary. So that would be the turning points, the different vertices and what have you. Now, using that idea, we can just draw a very rough sketch of the curve. And so we're going to draw 3x squared minus x cubed. We're going to find the stationary points. Now, when it says determine their nature, all they're really saying is, well, is it what we call a maximum turning point, so it sort of is up the top, or is it a minimum turning point, so it's down the bottom? Well, we're going to find our derivative, 6x minus 3x squared. The key to when it changes from increasing to decreasing is when it's stationary. So I'm going to find that point where it changes. And so stationary points occur when that derivative is equal to 0. So in other words, I want to solve 6x minus 3x squared equals 0. Now, when you're writing your solution down, write that line in. It's a bit like geometry, because what you're doing is you're, I guess, writing your reason or your justification. Why are you solving this equation equals 0? Well, I'm solving this equation equals 0 because I know that the stationary points will occur when the derivative equals 0. So we go and solve it, and I get two possibilities, x equals 0 or x equals 2. So I now know, and I can sub back in to get the y values. Logic tells me which one would be a minimum and which one would be a maximum because of the y values. As there's only 2 points, it would be unusual for the minimum to be above the maximum. If I had several points, it would be a bit harder to tell. But another way I could tell is to draw up a table of values. But instead of looking at the y value, I just look at the sign of the derivative, because that'll tell me when the curve's going up or when the curve's going down. So my table of values for the point 0, 0. So in the middle I've got 0. I know that the slope is 0, so at 0, I know it's a horizontal tangent I would draw in, or a stationary point. I'm going to pick a point on the left-hand side and a point on the right-hand side, as I say. The only rule is don't go past another stationary point. So on the left-hand side, I could pick any point I like. There are no more stationary points on the left-hand side. But I want to make life easy for myself, so I'm just using -1. And when I sub in -1, I get an answer of -9, so I know the curve's going down at that point, because it's got a negative slope. I'll pick a point on the right-hand side, but this time being careful not to go past 2, so I guess logically I'll pick the number 1, sub that in, and it turns out to be +3. Well, the actual 3 I'm not overly concerned with, it's the positive I'm interested in, so I know it's going up. And the red lines that I've drawn in, basically, it tells me exactly what the curve's doing. It's going down, stationary, going up. It must be a minimum turning point. Now, when you're drawing these table of values, don't just draw lines and go, oh, it's going like this. Put the values in that you're using so they can see which number you're substituting in, what was the value you got for it, and things like that. Let's have a look at the other one, 2, 4. So again, in the middle we've got 2. I know it's stationary there, so horizontal tangent. I want to pick a point on the left-hand side and the one on the right-hand side. Well, it's kind of obvious which one I'm going to pick on the left-hand side because I've already found 1. So I may as well use that one again. We know that was 3. And on the right-hand side, I can pick any number I like because there's no other stationary points. I can just use 3. Sub that in, I get -9. So it's going up, stationary, going down. There must be a maximum turning point. Okay, let's plot those points in. There's 0, 0. There's 2, 4. And there's a really rough sketch of the curve. I haven't bothered to find out the x-intercept or anything like that, but at least I've got an idea of the shape of the graph, what it's doing. Okay, that's all I want to talk about today. Here we go.